like to invite the head of the working group in the government of Great Britain, Vice President on IT modeling, AECOM, David Phil.
Спасибо and доброе утро, Moksvar. Ladies, gentlemen, and indeed friends, it's a real pleasure to be here today in this wonderful city and this wonderful facility today. It's amazing how much the journey has been, I've seen in Russia, in terms of not just building information modeling, but in terms of the digitization. It's hard to believe that it's Autodesk University Russia Day 2. Yesterday we saw so many magnificent things happening, and I think for me it's a real privilege to be with you, the leadership that's moving this journey on in terms of what's happening in Russia. And I think one of the things I see as well, this conference is becoming a real key in terms of global learning as well. So you should be very proud of the journey that you're on within Russia today. So what's my session about? Well, it's an opportunity to share my thoughts on a new area. It's where construction, as we know it, is entering a new area. And in terms of maybe a new construction agenda, we'll outline a new relationship in terms of how technology is driving what we believe to be exponential changes in our construction environment, and what that will mean to you as construction professionals in terms of how you plan, how you design, how you assemble, and how we operate our assets as well. So we think there's fundamental change going on. Building information modeling, as we saw yesterday, is a central plank, but we're starting to see it combining with many other things, as we heard yesterday. Design for manufacturing assembly, Internet of Things, all converging to create a new era in what we're doing. So who am I? Well, my name is David Philp. I work with AECOM, and for the last 25 years, I've been part of construction. So 25 years means that I've been very young for a long time within there. I'm a construction manager to background, but for the last 10 years, I've been working in terms of digital programs for especially UK government and Scottish government. And I think one of the things that we've learned about BIM and digitization is always having this thing called purpose, always having purpose in what we do and value. And whilst we talk about technologies, we never forget this is a people business as well. We need to think about processes that involve integration, and we need to think about the new behaviors as we try and change them as well. You're probably realizing from my voice that I'm not from Russia, but I come from this place called Scotland. And you can probably see from the slide there, this is our capital city of Edinburgh. It's actually quite similar to Moscow. I was out walking about on Tuesday, and you see actually, you've got wonderful heritage. A lot of your buildings already exist. So whilst we talk about doing more for less, we've also got to think about your existing building stock. How do you do more with what you've already got? How do you use BIM? How do you use our technologies to get better outcomes from our existing assets as well? And actually, whilst they're the same, I think it's fair to say in Scotland, actually, we're a tad colder than it is here in Moscow just now. But we're not far. We're only 1,500 miles to the west, so please come visit us. In Scotland, we're quite small. We've got a population of around about 4 million. I think Moscow is about 20 million, but actually, we think we've came a long way in a short time within Scotland. In 18 months, we went from creating a strong BIM policy across all of our central government to creating digital pathways for all our government departments to digitize their ways of working. And you can see from the images there, we're bringing together BIM and laser scanning, trying to understand our existing estate as well and think about digitization and preserving what we've got. My day job is with AECOM. I'm sure many of you heard of it. We're quite unique. We provide infrastructure across the globe, across all the geographies within there as well. And that means we've got some unique circumstances. We've got 80,000 people within there, so in terms of digital working and big data opportunities. We also have offices here in Russia, and please come in and visit us. You know, we've been here for about 20 years. But actually, what does that mean? We've got 20,000 people across our business that are BIM practitioners, constantly moving data about. We've got 30,000 people constantly using tools like Autodesk 360 to share our design, our construction information, across the globe as well. So you can see from our stages as well that we share information right the way through that whole project life cycle. So we take a whole life cycle approach to our data and our digitization. So you can see there our asset digital life cycle. We also use these 12 phases to try and demonstrate and help standardize the way we look at our data. We call these our data areas, right the way through that project life cycle. And that can be from an object, it can be from a model as well, and that helps us characterize the different attributes within that object as well. And whilst they might move round about there, our data has specific surface. So we're very keen to try not to disconnect the data from one area to another. So we're thinking very much about data through that whole life cycle. And this is a term we use, frictionless data and data continuity. How do we manage data right the way through? So for us, it's still thinking getting the basics right in terms of information management. And I think this is going to be quite an exciting year because actually it's going to be the first time we start to see the production of international standards for BIM and information management, ISO 19650, part 1 and 2. And actually, it's about information growth, data continuity. We want to move away from the blue jagged line to thinking about data that grows right the way through. So it's starting to think about data growing right the way through design and construct, but also more now continuing those models right into facilities management and operation. Through Internet of Things, we can start to connect these models up, our 6-dimensional models, to start to take in live data feeds as well now in terms of operation and performance data. So it's thinking about operation growth. And I think that's the thing we've always got to remember as we look forward, we still have to get the basic building blocks right of good information management and data delivery. And I think that's a key thing for us. And actually, I think we're seeing a fundamental shift in thinking as well. All these ideas we've talked about, like design for manufacturing assembly, you can easily go back about 80 years and find reports. So why have we never done it till just now? And I think often the reason is we've asked the supply chain to change, but never the client. So I think we're seeing a fundamental shift in thinking with the client also taking an intelligent leadership role in terms of digitization. We're seeing the client that's now thinking about buying their data and thinking about purpose. And that needs a lot of support at times, actually thinking about starting with the end in mind. What's the client going to use with the data within there as well? So a client buying the data once, when, who, why, and how much data they buy, but always making sure it's got clear purpose. So building the data set first, buying a corresponding physical asset, and then having a digital twin that can be used to maintain and operate and optimize that asset. But actually, when we think about BIM, BIM's probably been across for many, many years now. And I think it's fair to say our sector, our construction sector, is becoming part of a smart, networked world. I think BIM has actually been a bit of a Trojan horse for actually disruptive innovation within our centre. And I think what we're seeing, we've heard in terms of the last one, more for less. We're seeing a world where we've got to get greater value through improved innovation and digitization. We've heard about impact of urbanization, carbon, all driving needs for more innovative ways of working. And you can see in terms of AECOM, we're working in terms of the better world, using Autodesk products to try and create new automated ways of working, bring it together with DFMA, and also thinking about data optimization, how to use it to actually measure and get better outcomes. And I think that's one of the big things. We're moving away from thinking about outputs, drawings, and thinking better service provision. How do you create better assets with better service provision with there? Press it really hard. Oh, there we go. Think back in your career. How many changes have you seen? Sometimes it's fair to say it looks as if construction has a very long tail for change. Can you see much difference in there? I think we've got improved in terms of safety and carbon, but it looks almost the same. We come up to date. It's very hard to tell the difference in 100 years, despite all these technologies within there. But the thing that we see now changing is our clients. Our clients are buying much more sophisticated products within there, new services. And actually what we're seeing now is we're not providing just buildings, but actually assets that create huge amount of data coming through IoT and telemetry within there as well. So we believe we're in a real time of innovation. But sometimes, as Bill Gates said, we often get it wrong. We overestimate the change in 1 year, but underestimate the change in 10 years. Look back at your life 10 years ago. What did your phone like? Did you have an iPad or tablet within there? So think about 10 years from now, what construction could look like within there as well. And it'd be quite frightening. One of the things, though, that's came through as a bit of golden thread over the last couple of talks is this move towards design for manufacture and assembly. The term, and we're seeing it with a lot of our clients now, is moving towards this model of the fourth industrial stage, Industry 4.0, a convergence of cyber and physical systems. Thinking about how we use this data, ubiquitous connection from our sites within there as well. And I think if anything, two key things, Internet of Things, but also data analytics as well. So why do it? Well, one of the big things that we see all across the world is this big challenge called productivity. And I think it's fair to say that globally, the construction sector, labour productivity, has been pretty poor. It's pretty much flatlined. You can see there in terms of that red line. And if you look at the top, the grey one, that's the world of manufacture. And if you look at construction, I think it's fair to say that we work all these hard hours, but never getting improved productivity within there. So one of the things that we've seen, especially in the UK, is how do we close that gap? Because if we don't, construction prices will rise, and it'll actually put a brake on our whole economy. So in the UK, our government is actually moving towards modern methods of construction by default. This is a transforming infrastructure process that's looking to try and close that gap and move construction from being something that's quite traditional to move it into that world of advanced manufacture and modern methods. And that's a huge change for us. But again, if you've got your biggest client doing it, then I'm sure it will start to happen. For us at AECOM, it's about starting to think about delivering future infrastructure. How do you do it faster? And that's just not on site, but in terms of the whole process, in terms of procurement, statutory regulations on site, and also in terms of doing it better outcomes as well within there. At the same time, one of our biggest challenges is still around about skills. How do we start to attract new digitally enabled staff that actually understand how to use these tools? And if we don't do anything, within 10 years, within 1 decade, we will decline our workforce in construction by 25%. And that's quite a frightening thought. And we're competing now with other sectors to get that best talent, that's computer skills and digital skills as well. So we're thinking more and more what we call the T-shaped digital native, to understand the whole life cycle in terms of the data era and understand how to use the tools, the processes, and the technologies that actually support the life cycle. But what we're seeing is a convergence of themes coming together, and I think it's fair to say we've seen them over the last couple of talks. Digital technology changing the way that we plan, we build, maintain, and actually how we use our social and economic infrastructure as well. And I think most importantly, how it's going to generate new economic models within there. So what we're seeing is over the next couple of years, this combination of how technology will combine with the Internet of Things and a new digital economy for construction. So within AECOM, we see 6 key constructs, what we call the digital genome, that are converging in a combinational way. Each of these has its own value, but the more we can bring them together, we see trying to create that transformational change within there. And right at the heart of it, we see this thing called, we'll come on to it, the digital twin, a digital representation of not just the virtualization, but the processes, the systems, and the networks that's constantly living and constantly changing. Well, why do it? We heard 2 things earlier, more for less, trying to do it with less money, less time, and less carbon. And the other side, the pull for actually how do we do more with what we already got? At the very beginning of the process, we see this key in terms of data capture. A lot of the work we're doing is existing sites within there, the brownfield site, where the process of data capture trying to get that accurate real-world information that's computer readable is fundamental. And we're seeing a mixture of different methods of doing it, from photogrammetry to laser scan. We're doing more and more in terms of aerial drones as well, especially in big infrastructure projects, trying to capture huge amounts of information and data. And then how do we make sense of it? We're starting to see machine learning helping us make sense of torrents of huge data coming in from scanning. And you can start to see what this does, this point cloud here. Again, another heritage project. So we can start to stand the real-world data from there. It can help us plan for maintenance. But we can also start to bring it together as well with other components. This model here, you'll start seeing it going into the basement in a second. And what we've done is linked it up to other sensors. You can start to see there looking at the moisture mapping within there. So helping us plan, monitor conditions, and actually influence our asset management strategy. So combination of sensor technology and surveying. Same building. This is looking at an external wall within there. We find that heritage project, they take specialist conservation within. So using machine learning, we can take the scan, and we can quickly use it to automate using algorithms the number of stones within there. We can look in terms of the mortar joints. We can automatically measure it, 1.5 kilometers within there. We can also look, again, using the algorithm to actually see how deep the mortar joints are. You can see the heat map there. So we can start to, think about the mortar depth to inform maintenance decisions. We can also take that computer learning to start to teach it in terms of work out where the defects are. So again, automating that whole process. But early days of machine learning that was traditionally done by experts in the field. Our next one, at the heart of things, is this world of digital engineering. We're seeing many clients now taking together all these different concepts. So what's digital engineering? Well, we like to think is that world of connecting emerging technologies with reliable and structured data, especially from the world of BIM. Virtual design and script gives us that collaborative working, along with the real world that geospatial information gives us. And I think the key to it is VDC, bringing together people round about that model environment. At AECOM, well, we take our own medicine. You can see two different towers there. Tower A was done traditionally. Tower B, where we use this digital engineering concept, and Tower B is even taller than Tower A. We took 2 years using these processes of the services coordination. We're getting much better reliability within there, so bringing technologies and people together. And I think that's a key thing. Collaboration, bringing together supply chains as well. So what's BIM doing? It's helped us make smart decisions. We're doing much more as well from the VDC in terms of simulation. We're using it, you can see within there, in terms of stadium development to try and better understand plant, logistics, and safety. We're also working in areas which have got much more urban density as well within there. You can see this observation deck in the heart of Manhattan. We're using it to plan logistics, to simulate how do we get it there. We're also using it to work the jigsaw of actually how you do it and assemble it. The VDC model, it helps us work with stakeholders so they can understand the whole process as well there, understanding that whole sequence through there that was never understandable in a two-dimensional way. And indeed, what are we doing over here? Well, our team in Moscow are doing projects such as the Dynamo Stadium. And you can see there, it's actually made up of 500 models. So huge amounts of models to manage as well within there. And again, it's about bringing people together to understand that complex geometry. You can start to see the roof structure coming in there. We're doing projects as well, again, and we're starting to see mega BIM projects. This is out in Kuwait Airport. And again, just look at the key facts, the size of that model. The airport there is the size of the Monaco City Airport. Well, what does that mean in terms of BIM? Well, we're doing lots of different things that are beyond the general 3D. And you can see within there 300 models, but look in terms of the number of millions of BIM objects that we've got to manage. That's been done by 8 teams across the world. So we're using technologies to share information globally. We're now starting to think about design that follows the sun. So much more rapid design cycles coming there as well. But at the same time, with all those objects and all those models, we've got to think more and more about actually how do we focus on object management and quality assurance of the model process. So we're developing our workflows that look in terms of data provenance, model validation and verification, becoming increasingly important in our workflows. Pulling them in from the cloud. And again, we're starting to think about automation, rule-based checking, validation and verification of the data, and also trying to make sure that we've got good quality dashboard reports so our leadership teams can understand it. So using a mix of proprietary tools and some of our own scripts to better understand that QA process, which is hugely important when we have multiple teams working on our projects. We're also starting to see a much more move towards data analytics, especially in terms of design management and project management within there, to address issues in terms of safety and quality within there, and let our project management tools, who never normally use BIM offering tools, understand and be able to understand the dashboards and the progress and issues and activities as well. So making BIM accessible to all is becoming key as well. We're also seeing a move as well towards that world of parametric components. This is a government department in the United Kingdom, our highways agency, roads and bridges, who are moving towards the creation of catalogues of parametric objects to facilitate the mass adoption of customization. So thinking about standard libraries that work for that world of design for manufacture within there. The other thing is they're starting to enrich all these objects with rule sets governing their visibility distance, maximum distances between components, and interactions with other assemblies. So departments that are creating objects, but also data-driven rules that sit behind it as well. And you can start to see that move towards the likes of Dynamo and more thoughts by clients in terms of how do they automate that rule book in terms of scripting. So data-driven design, with the support of Autodesk, has given us real design time savings, especially in the world of complex geometry. And you can see it in this project here, some of the savings, huge savings again, using likes of Dynamo, the data-driven investing in scripting as well. And I think for one of the things for us, it's becoming more and more about working in partnership with our vendor communities as well. The next theme for us is thinking about the immersive environments within there. We think of it as allowing that humanization of design. We can now rehearse, we can optimize the construction functionality of our built assets through early AR and VR integration. We're moving towards that world of gaming technology with the likes of Unity, Unreal, to help our stakeholders better understand it. Better storytelling, and I think de-risking of the process as well. This is a project just now in the UK, it's called High Speed 2, our big high-speed rail civil project. And you can see there, it's bringing the prototype together, the world of the physical and the digital. So stakeholders can start to experience the service outcome within there and give us feedback. So we're starting to think about it more and more, actually that virtualization of the service provision, the customer experience. We're using in projects, this is a fast-track project in Cameroon, 50,000 seats within there, and we use the VR not just for the construction process, but help the end user understand where their seat would look like within there. So a highly simplified process that's helping people to understand and actually sell their service provision within there as well. And we mentioned that we do our design often across the globe, so we're starting to see AR and VR technologies helping us pioneer in terms of sharing design. We're also seeing a move towards wearable technologies as well. This is a Crossrail project in the United Kingdom where the AR technology has been used for facilities management, that those that maintain and operate can pull in all the data that's going to help them during these final operational stages as well. So augmented reality for operational stages becoming key what we're doing. It's also helping the augmented worker, the construction manager, make better decisions on site during key there, being able to pull in key data. Similar during the facilities management, being able to pull in operation and maintenance instructions at the click of an eye. We're also seeing a move to our assets changing dramatically as well. Our assets that were once dumb and disconnected are getting smarter. And what we're seeing as well, our infrastructure is starting to create streams of data that can actually start to bring us, if you like, we're seeing it actually is creating all this data, and we've got to think more and more about how we can measure and improve. So data analytics becoming key for what we're doing. We're also starting to think more and more about the social infrastructure. So using IoT to start to think about social benefits. How do people actually use their infrastructure as well? So looking at user data and movements within there as well, invaluable. Tracking movements as to actually how our users actually use our spaces from there, giving insight and opportunities for actually improving the assets within there and there, finding ways to push ways for users to travel areas much less as well. At the same time, we're thinking about other sectors as well. We look at the world of Formula One. The amount of data they pull in a typical race is incredible. How do they start to use all that data and analyze it as well is becoming key. So we're learning from them, especially about the Internet of Things, analytics, and edge technology. So we're pulling a lot of our measuring devices now right to the edge on the data source as well within there. Because key for us is measuring all these terabytes of information. Well, what can we do with it? One of the things now we're seeing moving into a world of what we call continuous performance within there, we can actually start to measure, we're connecting our BIM models up to our building management systems. So we can look for patterns start to happen. We call it our pre-failure mode. We can find anomalies before they actually happen, making sense of huge amounts of data. You can see the example there where we can see patterns of change happening, so we can actually repair before fail, which got a huge impact for us and our clients within there. So analytics, simulation, hugely important. And you can start to see that move towards the edge. So we're actually putting our measurement devices as close as we can to the sources of data. So we're not having to take huge amounts into the cloud as well, allowing us in terms of volume and veracity of data, doing it much, much faster within there as well. I think it's fair to say one of the big things for us as well is information management. I think it might sound obvious, but I think it's fair to say it's changed our life, and it's changing the way construction operates as well. And I think as an industry, we've got to think more and more about being information-led in what we do. And for me, that information management frameworks, having indexable and searchable information is hugely important. In the UK, our next trajectory is called Digital Built Britain. And it's trying to think about information that flows right the way through the cloud. So if we look at it, our first part has been BIM and virtual design and construct, helping us better move information during these early stages. We're now starting to move all this information into the world of operate and maintain. So we're starting to think about the 6D models, the information management framework to support there, moving into a computerized facilities model and asset management. But we're now thinking about the world of optimization and actually how do we get all this data into portfolio level to where we can start to gain exponential value as well. And ultimately, we get the real value of the optimization when we move this into portfolio level, and we actually can analyze our buildings real-time post-occupancy evaluation. We can understand how in real time they're performing, and we get systematic learning. So information going forward and information going back. Now that actually requires a lot of work in terms of information management landscape, building the frameworks around about it to do it safely, fast, and secure. This is our vision in the UK. As we mentioned, it's called Digital Built Britain. It's part of the UK government's next trajectory. So you can see there the key, moving information forward through buildings, portfolios, up to smart city, but at the same time, being able to learn from it systematically with there as well. It'll help to inform demand, it'll help to inform performance within there, and it'll shape future capital investment. We're also at the same time, and I think we've heard about it many times today, the advanced manufacture process within there. And for us, it's a lever for improving that productivity. You can see the typical investment we're now starting to see being made by that construction community. Factories that might be taking through precast concrete, but we're thinking about models that are going straight to the computer. So we're thinking more and more about configuration. And I think that's a big change in what we're doing as well. Projects, big infrastructure projects in the UK have made savings of around about 70 to 80%, bringing digital engineering and design for manufacture together. We can see there the savings versus in situ versus that precast, straight from the model, about 80% savings in terms of the time plus the quality factors as well within there. This is actually up in Scotland. We've got, it's called the Construction Scotland Innovation Centre, and we're starting to bring the world of robotics together. This is a government-funded project where the supply chain come in and can test new ways of working. The digital prototype using robots to test and inform as well. But we are now starting to see that world of convergence with robotics as well. And starting to think about the appropriate ways how BIM can help us inform the best ways of achieving it. And you can see some of the savings that we're making in terms of ACOM. We started to prototype all our healthcare, and we're getting savings in terms, massive savings in terms of cost and time and quality within there as well. Our next one is what we call the digital twin. And this is a big aspiration in the UK to actually create a national digital twin. And you can see it starts to link up not just our buildings, but our energy, our environment within there, so we can smart real-time decisions on the future. It gives us resilience. It helps us think about joined-up planning as well within there, transforming the way that we'll manage and use our national infrastructure. It's a massive big project. It'll take many years to do, but it's backed by our government and the Centre for Digital Built Britain. And it's starting to take all our 6D model environments and federate them together. So we're starting to create now much more digital twins that are bringing together that mirror of the physical with all their data and information, helping our owners and operators make much better investment decisions. You can start to see the typical project. This is one at Denver Airport, which we've done, and you can see at the heart of it, BIM, databases, mobile technology, sensors, all coming together within there, so we can get understanding of operational system, geospatial, all our application developments to make smarter decisions on the field as well. And you can see there again, starting to make in terms of how that building's been used in terms of footfall and actually condition of the operational runways as well. And we're starting to as well move into this world of the smart cities. We've been doing prototypes within there, linking up all these different data sets, trying to unify all this asset management together and linking up to energy systems, CCTV, and other smart devices as well within there. So trying to create that whole semantic model as well. So going from individual assets to portfolios to digitization at a city level to make much more well-informed decisions there. Bringing together IoT, BMS, and all that other open data as well that's becoming so sensor-rich as well. Well, where are we? We generally think we're on the cusp of a new frontier in terms of project delivery and operation. We think it's an era of collaboration and connectivity. And I think it's important that you use your time at Autodesk University to reflect. Think, what does your next 10 years look like? What does your plan look like from technology to processes to training? And think about what that new ways of working are going to mean to you, your business model, and your staff as well. So my advice is use your time wisely. Learn new things for the learning, but also share and connect as well. And I think if we've discovered one thing in our journey, it's much easier when you go on this journey together. I think that's a key thing for us. The future, who knows what it's going to look like, but you've got a great opportunity. We're extremely impressed with the things we've seen over the last 2 days within there. So, spasiba, thank you for listening.